Hey there, Algebra 2, Mr. Rising here, wearing the pea flower on my head. In this lecture, I want to talk about complex operations, and of course, this is things involving I, the imaginary number. And before I get rolling on this, I just want you to introduce you to Kai. This is my oldest son, Kai, when he was about not quite 2 years old. And you'll see this picture on my background, so ask me about it another time. And the big thing about complex operations here is just get your hat on, okay? Hang in there. You have been doing something abstract in mathematics for quite some time, and that is learning the operations or the order of operations. Like, think about PEMDAS. When we do PEMDAS, you know that, let's say, a squared is really a times a. Well, you know to do that regardless of the value of a. And so what that means is you've learned an abstract process. This is what it means when you see this squared combination. Well, the same thing is true in complex operations, and really it's getting you ready for pre-calculus and calculus where you have functions and processes that you need to manipulate. So rather than saying, I can't visualize what this is, think this is a process that regardless of whether it's a number, a variable, an imaginary number, or an expression or a function, you can take that and put it through another function or another process. And so that's really what we're talking about in the big picture. Today's specific example, though, is we're looking at performing operations with complex numbers, right? Arithmetic, subtraction, multiplication, division, those kind of things. So the first thing to note, and I'm really following the book here, so if you want to go along with me, that's fine. The first thing we want to note is we can represent these graphically on a complex plane. And so here it is. The x-axis is the real axis, and the y-axis is the imaginary axis. So think of it still as like it's in the form a plus bi, but really you can think of it as x plus yi, where y is up and down, but that's the imaginary part. Okay, so let's try this. I'm going to get out, Sadie, what color do you want? Purple. Okay, I'll do purple. All right, so graph each complex number. So 2, I'm going to go over to 2, negative 3i. 1, 2, 3i. So I'm going to put a little a here so you know what I'm talking about. All right, b is, John, what color would you like? All right, red. All right, negative 1 plus 4i is going to be up here. All right, C, Eldon, what do you want? You want green. All right, 4 plus an i, so I go over to 4 plus an i. And of course, D, Josh, what color? Blue. All right, negative I, that means 0. X is 0, so I'm on my x-axis, and negative 1i, I should just be down 1, just like that. What I'd like you to do is try this set. Go ahead, pause the video, and plot these points. All right, Mr. Rising's back. Hey, I'm going to just do all of these in, what is that, teal, aqua, something like that. All right, here we go. 3 plus 0i means I'm just over at 3. 2i, 0, 2i is up here. Negative 2, negative I is down here. And 3, 1, 2, 3. Oh, I've been at 3 before, but then I go up 2i. So I should be right there. So there's a lot of little examples in this section on complex operations. Let's just move through it. And again, pause when you need to. If I'm going too slow, speed me forward. This slide is talking about when you find the absolute value of a number. It's really the distance, right? So when we think about absolute values, we're thinking about distance. Well, when you do the absolute value of a complex number, it's really these values, a plus b squared. And take a look here. So if this was 3 plus 4i, this point is 3 plus 4i, how would I find this length? And you're like, oh, well, it's really the Pythagorean theorem. Take the one leg, square it, add it to the other leg, squared, and take the square root of that, and you'll get the distance. And that's exactly what we're doing here. So when you see the absolute value of a complex number, the a, the b, again, not with the I, but just the b, and then square both, add them together, and take the square root. So let's look at some examples real quick. So if I have the absolute value of 3 plus 5i, again, 3 and 5, fair enough. I square both, I add them together. Same thing with the negative 13. We're like, what do you mean the negative 13? Well, there's no I, there's no imaginary value here. So you just take the negative 13 and square it. That's 169. Take the square root, and that's 13. Similarly here, when you have no x, real x coordinate, you just have an imaginary. Well, you're negative 7 units down, right? Square negative 7, you get 49, and the square root of that is 7. So what I'd like you to do is try these problems. They're in your book. Pause the video, come back when you think you have solutions. All right, here you go. How did you do? Take a look there, right? And we leave everything in the most simplified term. Next thing we need to talk about is adding and subtracting complex numbers. Khan Academy loves these kind of operations, so just keep that in mind. Now I'm letting you know it's about 7:28, so people are rolling into school. So if I have to stop the video, just, bear with me. Now, let's try a couple. Additive inverse means if you want to eliminate a plus bi, well, subtract a plus bi, and that would distribute that negative sign to the a and to the b, so that would be the additive inverse of a plus bi. So try this one, add or subtract. 4 plus 2i, hi Brody, plus negative 6 minus 7i, and simply combine the real terms and combine the imaginary term. Hey, that was Brody. He was just in awe of my my flower hat. So anyway, okay, so here's what I want you to do. Try this operation. Pause the video, tell me what you think. All right, you're back. And again, there's only a negative 3 real term, and you've got a 5i and a negative 6i, which leave you with a negative I. Now the real question here is, do you prefer the screen shade or the little box? What do you think, box or screen shade? You tell me. All right, the next thing we need to look at is looking at these operations by graphing them. So this is what the book shows you. It says, hey, when you get this expression, graph 3 minus I and graph 2 plus 3i, and then put little lines that go back to the origin. And then what you need to do is make a parallelogram, right? Well, you're going to go, the same slope. And I look at this and I'm like, that's absurd. Why wouldn't you just treat it like a vector? So this is how I want you to consider doing it as well. So if you have a little piece of graph paper, let's do this. Let's check it out, example 4a. So we're going to go to 3 plus 4i. So let's graph that. And Riley, what color would you like? Yellow. Okay, we'll do yellow. I can do yellow. That's fine. All right, so let's go to 3, 1, 2, 3, plus 4i. So 4i is up. 1, 2, 3, 4. So this is my point in yellow right here. All right, that's that one right there. And now, Neela, what color would you like? Some kind of green, olive green, middle. We'll do this green here. So what I'm going to do is add 1, positive 1, right? So there's 1. And minus 3i is going to be down 3. 1, 2, 3. So that's minus 3i. So which means my final point ends up here. Now, if you prefer to make the parallelogram, go for it. For me, it's just easier. I'm going to take this point here, right? I'm going to have a starting point, and I'm going to have the operation that I need to do. Furthermore, multiplying or dividing complex numbers, of course, you can distribute or undistribute. All right. The key here is, that you do distribute fully. So this I is not only going here, it's going here. And of course, now we have to remember all our I powers. So I squared is just negative 1. So this is really negative 4i plus 8 times negative 1. And again, we write that in the form a plus bi. All right, your turn. Try this one out. Pause the video, see what you get. All right, you've distributed the 2i to both terms, and you wrote it in simplest form. Any questions? So if you have any questions, email me or write this down. Write the question down, and we'll talk about it in class on Thursday. A few more examples. So we talked about this table before, and what we're looking at here are powers of I. And my general rule was, if it's odd, take out an I, and you're going to have an I in your answer. And then look at the remaining power. If the power divided by 2 is even, it's positive. If the power divided by 2 is odd, it's going to be negative. So for example, here, if you said 7, so take out one I, so you've got really one I, and you've got I to the 6. 6 divided by 2 is 3, so I to the 3rd is negative 1. This is another great pattern. Khan Academy loves to test your knowledge of it. If you want to talk about this more on Thursday, let me know. We can do some more examples of it. Really, but then they're going to just hit you over the head with examples too. And what do we have here? Negative 6 I to the 14th. Oy, oy, oy. Well, here you go. When they said it's even, it's really this negative 1. And negative 1 to the 7th is also negative 1. So negative 1 times negative 6 is equal to 6. I would do it slightly different. I would say, hey, it's even. 14 divided by 2 is 7. So I to the 7th is going to be a negative, or not I to the 7th is negative 1. But this value, when you evaluate it, is going to be a negative 1. All right, your turn. Again, I'm back with the screen shade. Try this one out. Simplify 1/2 I to the 7th. Survey says negative 1/2 I. Pause it if you need to walk through the steps there. I think I've just got 1 or 2 more slides here, and we're going to talk about this. When we studied radicals and square roots, remember that you can't leave a radical in the denominator. So in order to get rid of that radical in the denominator, you multiply the whole value by 1. Well, really this is really 1, but you're multiplying it by the square root of 2 over the square root of 2, and that leaves you with 2 square roots of 2 over 2, and of course my 2's cancel out, and this is just really equal to the square root of 2. Well, the same thing is true when you have a complex number in the denominator. What you need to do is multiply the numerator and the denominator by the complex conjugate. What in the world does that mean? Well, check out this example. First of all, I've got a 5i in the denominator. The complex, so it's really 0 plus 5i. Let me just write that in here. This is really 0 plus 5i, right? So what I need to multiply both the top and the bottom by is 0 minus 5i. That's my complex conjugate. And when you carry out the operation, you get a negative 25i squared in the denominator. I squared, of course, is negative 1. So negative 1 times 25 is 25. And you simplify everything out. Again, 50 divided by 25 is 2. And then 15 divided by 25 is 3/5 I. So this one, I want you to try this one. It's a little more complicated, and so maybe I'll give you the first step. Well, actually, go ahead. Think about what you'd multiply the numerator and denominator by. Of course, it's your complex conjugate. And then try to do the rest of the problem. So pause it, and here we go. We're back. Now, if you didn't use 2 plus I in the numerator and denominator as your complex conjugate, go ahead, stop where you were, go back and fix it, and then carry out the rest of the problem. All right, and again, here we go. We're multiplying binomials. You'll notice this is the difference of squares. So that means you'll eliminate any of the middle guts when you FOIL it. That make sense? Difference of squares has no middle in it. And that's what we're trying to do. We're trying to eliminate that middle. You will be doing this the rest of your mathematical careers in calculus and pre-calc. How to get rid of funky numbers in the denominator. All right. From that point, it's a simple, straightforward, it's just a simple 7/5 plus 1/5 I. Yeah, simple, right? Hey, great job today. I hope you enjoyed having Kai looking along, having a little pea hat on my head, and we'll plan on having just a short little quiz on this first thing in class on Thursday.